Hey there, everybody. Welcome back. We're doing one more three-dimensional Jacobian example. We're going to find the volume of an ellipsoid. So x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. We're not going to look up the formula. There is a formula. It's not well known. But the form suggests the change I'm going to use. In fact, I used u equals x over a. So u squared is x squared over a squared. And that gives me x equals AU. For v, I said b equals y over b. So b equals y squared, b squared equals y squared over b squared. And y equals bv. And the same thing with z and c with w. So this integral, we're doing volume, so the function equals 1. So we're integrating a 1 with respect to dx, dy, dz. It's the limits of integration that are pretty crappy on that. But when we switch over to this, we can now do it slightly a bit easier. Let's find the Jacobian though and rewrite everything. So dx, dy, dz with respect, or I'm sorry, the partial of x, y, and z with respect to u, v, and w gives us this matrix with a0, 0 along the top, 0b, 0 along the middle, and 0, 0, c along the bottom. The determinant of that matrix, since it's just the diagonal, is ABC. You can go through and work it out, but you'll learn that, and again, in linear. The determinant of a diagonal matrix is the product of the diagonal components. So I've got ABC is my Jacobian. So now I've got the volume of this thing, but what happened to x? Let's come up here and look at something real quick. I had x squared over a squared plus y squared over b squared plus z squared over c squared. Making this substitution, I have u squared plus v squared plus w squared equals 1. I've got rho equals 1. This is a sphere. The volume of a sphere is well known. It's 4/3 pi r cubed. So I can factor out the ABC. I'm finding the volume of a sphere because I've got a 1 in front. The volume of the sphere is 4/3 pi r cubed. So 4/3 pi times ABC is what I should get. You can work this out in spherical coordinates. Doing another substitution, I recommend you give it a try. Switch from UV to W over to rho, phi, and theta. You will confirm that rho squared sine phi is the Jacobian for this transformation. And you can integrate this as a sphere using that. I didn't work it out for you because that's left to the viewer. Peace. That'll end this chapter, and I'll be going over center of mass afterwards. Peace.